so for 1, 2, 4, so for the first lap that I'm going to take, because I'm kind of debating what to do about the people that I have like copying things, you know that just answers won't get you credit unless it's like a really straightforward question. So like on the back, where you're being asked, like to find the mean, like in 92 or like in 93, I don't really want to show my work to you right now. Because I got some people copying their homeworks, and very soon it's going to become an issue on the next mastery, which is next week. So if any of your answers are wrong, you can like ask me to come over there and we can talk about why, but I'm not going to show my work today because this homework is a really good checkpoint for do you know what is going on. If you couldn't do these problems, your first step should have been CPM homework help, right? Or check math notes. I guess that's like step 0 is like check math notes. Then you're able to access my answer key, right? I don't really need to put my answer key up every day because you have access to it. Now this, just the straight up answers, you don't have access to because that would just be silly. That'd be like too tempting to just go look at the answers. I want at least, if you go look at my answers, that you see what I did. But are there any big questions that like your answer's way out in left field and you're like, I really don't know how they got that? Because I'll walk through it. I just don't want to show all of my stuff because I got some people copying. And we're taking care of that slowly. Any big questions? Margo? You mean like 94C? So in 94C, what? What do we need in order to add or subtract fractions? Jana? We need to have a common denominator. So guys, your reminder for how to find common denominators, and people mix up the vocab on this all the time, we need to think about multiples, not factors. Factors are the smaller numbers, multiples get bigger. So our multiples of 9, and then while we're listing our multiples of the one denominator, we're looking for one that is also a multiple of the other. Got it. 45. So today we're going to review what we do with these problems. And guys, a lot of times the last problem on the homework is a little challenging. That's on purpose. So what I need to do is change my 9 into a 45. How do I change 9 into 45? Okay. And if I do it on bottom, I also have to do it on the top. Over here with my 5, what do we multiply by? 9. And if I do it on bottom, I got to do it on top. So this really becomes 25 over 45 minus 9 over 45. So then, how do we subtract fractions? Ivan?
Since you have both of the common denominators, we just subtract 25 by 9.
So what is that?
16.
And then the denominator would be?
45.
Because that stays the same. So that's how we get to 16 over 45. Does that make more sense now, Margo? So guys, some days, this is how we're checking homework. I'm not putting on my whole answer key because I got too many people like frantically copying. If you're gonna copy my stuff, do it on your own time. Sorry, but like, I got too much to do. Alex?
Is there a way you could explain it in a different way?
I mean, I can explain it with pizzas.
Oh, yeah.
So, yeah? What kind of pizza do you want? You don't want pizza? Okay. All right. So I have 2 pizzas. My one pizza is cut into 8ths. And my other pizza is cut into 6ths. But my pizzas are the same size. So cut into 6ths is a little bit tougher to draw. sorry. Imagine that these are all equal size pieces. You guys know with pizza that doesn't always work, but imagine that they are. Right now, this is saying I have 3/8 of a pizza left. I would like to eat 1/6. And sorry, at first I thought we were adding, so that's why I drew a second pizza. But we don't actually have a second pizza because we're trying to subtract. I want to subtract. I want to eat 1/6 of a slice of pizza, right? We'll add some pepperonis or something. Can I take 1/6 out of here? Well, kind of. Because, like, I bet there is a 1/6 worth of pizza, but is it 1 slice or 2 slices? Or, like, we don't know because these slices are 8s. So what we have to do is cut both pizzas into more. So, what happens if I cut every one of these slices again? What's like 8 times 2? 16. I could get 16 slices, right? So I could do this, 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 this. Yeah? 16. What happens if I do 6 times 2? 12. So that doesn't quite help yet. And we have to keep cutting the slices up until I find something that is the same size. Now I'll write out the math of all, like, what that just did. So the math of that is with 8 and 6. I'm thinking about 8, 16, 24. Aha! If I cut my pizza into 24 slices, well, 6. So I need to go times 2, times 3, times 4. So this is really... Guys, I sure hope you're listening because there will be a question just like this on the mastery. So this is really 9/24 minus, we would do times 4 over 4 minus 4/24. And then because our denominators are the same, just like what Ivan told us, once they're the same, they stay the same. We subtract the top. Yep, that's how much pizza we have left. Thanks. The blue doesn't show up as well as I wish it did. All right, so that's really probably all the time that we can spend on that. If you need more help, come see me. Or email me. I'll make request videos. Right, text me. Somebody actually texted me last night, and they didn't need to, but they were like, hey, I forgot to tell you I got my mastery done. I forgot to turn it in. They didn't really need to, but, like, I think they were stressed. So, like, okay, cool, great. All right, if 1, 2, 4 is done, turn it in. If you need to see the answers again, there they are. But aside from that, make sure you have work on it, or it's going to come back to you. So the next thing we're going to do is going to be one of those, you can draw it if you want to, but you don't have to. So, oh yeah, that's just not plugged in. So I wonder where it's recording the secondary from. You don't have to draw this. But what we have here is like a 5x5 square, right? But actually, if you're going to draw it, if you're going to draw this, and guys, if you don't have 1, 2, 5, you should grab it off the back, but this is not in 1, 2, 5. We'll use that in a second. If you're going to draw it, go ahead and draw it like this. If you don't draw the square, I still need you to, on your graph paper, write fraction conversion. And we should probably give this a date. What's today's date?
The 8th.
The 8th. What fraction am I showing here with, like, what is shaded green? I should probably start using random cards, otherwise Gabe is going to take my job. Keep letting you answer every question. I talked to your mom last night, actually. Yeah, I told her how awesome you are. I hope, did she, like, come home and give you ice cream or something? Seriously, I talked you up, man. I told her, you sit in the front, you're excited, you're one of my favorites. She was happy to hear that. You're all one of my favorites. You know why?
Yeah,
Sure.
Totally.
You know why? Because you chose to come to Phoenix. That's what makes you one of my favorites. So, Christian, what does this show? Like, how many are shaded versus how many total? And guys, if you want to draw this, my advice is grab a ruler, get yours out, or get one from the back. You don't have to draw this, but if you want to, it would be beneficial. Christian, what's this show us?
There's 15 unshaded and 10.
Yeah, so if we write this out for what is shaded, we would probably put 10 over, how many total are there here? 25, right? 5 by 5 makes 25. There are 20. So go ahead on your paper, write 10 over 25. That needs to be on your graph paper. If you choose to draw the square, awesome. If you choose not to, okay. Now, just like our pizza, if we realize that 25 of these squares, I mean, we could even say this is pizza, right? Like Jet's Pizza kind of comes in squares. There was a pizza place in Coshocton that did square, which I've always thought, why does round pizza come in a square box? Let's just make pizza square. Which you could. Anyone know why pizza is a circle? And anyone ever baked a square pizza and realize what happens? It just kind of cooks different. So, like, yeah, just as you get into, like, baking and things, like square cake versus circle cake, like, things just kind of bake or cook differently. I could cut this, right? Like, I could cut it in really creative, crafty ways if I want to cut some diagonal slices, but I'll just work nice with my graph paper and cut it like this. So I'm just going to cut horizontally again to still make even size slices, because I know that my middle school students will yell at me if I make uneven size slices. Oh, trust me, Margot yelled at me this morning.
What? Which Margot?
You weren't listening, were you?
What?
I said I need to make sure these are equal size slices, because otherwise my middle schoolers will yell at me. And Gabe said, we will never. And I said, well, Margot yelled at me this morning.
Yeah, but I didn't yell at you about slices.
Right, but I'm used to getting yelled at. Are my slices all equal sized? Yeah, I've had some practice at doing this, right? So what did I just do? What did I just do with each slice? I cut them more specifically in half. But what does that do to the number of slices? It doubles them. So this would be times 2 times 2. So now how many shaded slices do I have? 20 over 50. And you can see where I'm going with this. If we do it again, like the other direction. Wait, what'd you just say? Well, no, what did Destiny just say? Can you say it louder? Because I don't think they can hear you. Otherwise, I'll repeat it. Yeah, Destiny said, oh, we're just making 100. Yeah, but what is the point? Where do you think I'm going with this? Why are we making this into 100?
Oh, so
Lily's so excited she won't even raise her hand. Percent! Oh, you think I'm that old?
yeah.
Guys, I gotta brag. It was a really funny moment last night. So I was in a fraternity in college, but not your average fraternity. We were a service fraternity, so we just did things to, like, help people, worked in the community. But I'm still involved with them, and I'm helping them recruit the next class of people. And last night I went to what's called like a rush party, where people come over and they have food and we have music and trying to get people to join our group. And this is a Phoenix alumni who is now at Otterbein and is thinking about joining our organization. And it was just one of those moments where I was like, oh man, I taught you like 8 years ago. And we got to catch up and talk about what he's been up to. And it was really fun. I also wanted to give you some time, because I know some of you are drawing lines and everything else. So this now becomes, and I'm going to write it in green to help reinforce this. How many squares are shaded green now? 40 over 100. Now look at Now look at 96. Now look at 96 on your paper. See if you can figure out what to do there. Now look at 96 on your on your practice sheet. 96. See if you can read what's on there. You need to copy 125. So, notice we're saying don't have that. They're right back here. And you can always check the top of this. So we need that note on 96 now. We're reading through it and seeing if we can process it. So since June is in the office and you want someone to talk to, it's right behind you. You guys could talk about this. Did I change the amount of pizza we had? No. Well, what do you mean, well, kind of?
You made more pizza.
Hold on. Did I make more pizza? Like I got out the dough, I got out the cheese. Did I make more pizza?
He's made more dough.
I created more slices, but the slices were smaller. So, Alex, I want to make sure we understand. Did I actually make any more pizza? No. Or if you want to imagine this as a cake or whatever, I didn't make any more. It's the exact same amount we started with. I just created smaller pieces. But if I still want to be equal to what we started with, everything has to get bigger. Right? So these are all equal to each other. Because what we really did, and what I want you to indicate, is that this right here, that's actually times 1. When you do the same on top and bottom, that's actually times 1. And multiplying by 1 doesn't do anything. Right? If I say I'm going to take your water bottle and multiply it by 1, okay, awesome. But if I say I'm going to take your candy and multiply it by 3, yeah, you'd probably be happy about
Yes,
that.
please do that. Please do that.
If I say I'm going to take your homework
No.
and multiply it by 0, what happens?
It becomes 0.
It disappears, right? Anything times 0, anything.
That's what you should do. Yes.
But that would be irrational. That would be an irrational.
You should do that. It's the best idea ever.
April Fool's Day, you should do that.
Yeah, April Fool's Day, you should do that.
Mr. Hudson, you have my favorite teacher going your homework.
Oh man, if only I cared about favorites. I want to earn being your favorite teacher, not just get it given to me.
You can earn it by taking away the homework. Yep.
I left my cards over here.
No. Oh, actually, I forgot to ask. You know, maybe cards and calling me.
Maybe cards and calling you?
Yeah.
Maybe. Raphael, if we look at A, it says, why is the fraction 4 over 4 called a giant 1? Do you want to give us an answer for that? Yeah, because if I take 4 and divide it by 4, like if I have 4 pieces of candy and I divide them to 4 people, everybody gets 1. So what we start to do to help us remember that is we kind of box it in with what looks like a fancy 1. Right? If you make a fancy looking 1, it's got a little top and it's got a little bottom. And we call that in CPM the giant 1. Jan?
I just want to answer the next one.
Okay, my card's next, so I guess you can go ahead and jump in. So for BI, I don't love how they started numbering these. For BI, what do you think, Jana? What's happening here?
Can I write it?
Fast, sure. Miss, you want to do double I?
I want to do the one where you like solve it on your own.
Okay. Nate, do you want to do double I? No? Ivan, you want to do double I? Like the 6/15ths and the 3/3? No, wait, 9?
Oh no, I wrote that thing.
You're looking in the wrong spot here.
Yeah.
Ivan, do you want to come like write what happens when we multiply by 3 on top and 3 on bottom? You can come up or I can do it. Like, if you want to come up, I think some of you guys like it. So, Miss, no, Ivan's coming to do it. Miss, you said you wanted to do I or double I?
Can I do both?
I'm not sure.
Wait.
You gotta talk it through. Oh, well, okay. Everyone else is mad. I gotta be fair, I guess.
Isn't I like a
Fine, I'll do the harder one.
Which one is that?
I don't know.
I don't know.
You pick one.
I'll do one.
All math is hard. Well, I'm using cards though.
Fine, I'll
You
do
wanna
I.
come up and do one? Addie, do you want to come up and do one? Yeah. So what everyone missed doesn't do.
I'll do.
So what's
Yours
6
is
times
different
3?
than ours is.
Did I put different stuff on the paper than what
Yeah,
I?
on 5 7 times blank equals over 70 is different than what's on ours.
No, it's not. It just looks a little different up
That's the
there.
same.
Oh no, the one
The
is.
one is over-
Yeah.
yeah.
So that is a typo up there. I don't know why that happened. You're good, Ivan. So real quick, well, I'll put my paper up there. I don't know why this is wrong. This when I copied over that one on your paper is right here, and that's where it should be. I can't draw with my left hand. So when we multiply by the same thing on top and bottom, it's really multiplying by 1, and it's not actually changing anything. We know the numbers change. It looks different. It's the same. So 9 times 6, 54. 25 times 6, 150. Let's see if we can get that.
Wow.
That. There we go. And then 6 times 3, 18. 15 times 3, 45. So these are what we call equivalent fractions. Fancy way to say equal. Equivalent fractions. So down here, Miss, come up and do I, but I'm going to switch what's on the screen real quick. Like I'm going to put.
4 or like is that a 4?
45.
Here, hold on, Miss. Just give me a second.
So how's your day, guys?
Amazing.
Horrible. My hair wet. Oh, that's bad.
My shoes got wet.
Well, I hope your day
Everything
gets
got
better.
wet.
I don't have a lunch. So.
Like into my shoes. It's all.
All right, so there we go. Fix the typo. Go ahead, Miss.
Okay.
Click on the pen. So remember, up top, click pen, click color, click pen, click the color. Wow, all the choices. Well, you might be able to see that. And then, yeah, you can kind of see on there.
Okay, kind of. So, basically, what I did was I reversed it. So I did 40 divided by 5, which would be 8. And then since it's the big one, went on the bottom. So then,
Mr. Hudson has a question.
yes, Mr. Hudson?
Wait, why did you divide when it says multiply?
Because I can't really figure out what the big one is. I could if I was going by 10, 15, 20, but that is too long.
So,
Oh yeah, Margot.
Yeah.
I was gonna say if you have to use division to reverse the multiplication.
if we don't know what to multiply by, we divide backwards. Alex,
You're not the
Yeah,
teacher
right.
right now.
Alex,
Mr. Hudson,
that's
you're
me.
not the teacher right now.
But the students are allowed to say things that the teacher said before.
Yeah.
All right, continue.
So
I'm actually like a teacher, Mr.
Are we good over here?
then I did 7 times 8.
Does all make sense? So what do we
And
think?
then obviously I had to reduce it, right?
Okay, what is
Yeah.
that?
I had to reduce.
Because if we don't know what to multiply by, we divide it backwards.
70 divided by 5.
So you don't have to reduce that, because actually, what is reducing going to get us back to?
Oh yeah.
No, but that's great. Leave it, because it shows us that those are all of those fractions are equivalent to each other. Beautiful. Big brain. That was deserves a mic drop. And Addie was next.
How do I? You got the yeah. You got the hand on. Straight, yeah.
You don't know how to multiply, we divide it backwards. So since we're doing multiply, you don't know
Yeah,
what times 7 is.
And I might not be able to show it. It's easy. You guys know your 10? Yeah. Okay. I think we should know.
Absolutely.
10, 23, 24, 25.
Why are you? I can't see with that one.
Yeah, it's a little dark. Wax on. Wax on.
No. Yeah.
No, Mr. Miyagi.
The new season is coming out soon.
So you were totally right. Just go ahead and write it up there again in a brighter color. Yeah, they'll be able to see. Let's make this smaller. Boom, there you go. Do you want me to narrate for you, or do you want to talk it out?
No, I can talk it out. So.
Talk to the class.
What is 7 times 10 equal? 70. Mr. Hunt, yeah. So I have a question.
Someone's teaching right now.
You can ask me the question.
Okay.
But it's not about that.
I think we have another typo.
Wait, was that 80? Am I just not seeing? Oh, 50. 50. Yeah, sorry. Last time you wrote it, I thought I saw 80. Yeah, be careful with 5s looking like 8s. All right, so go ahead and just for sake of time, what question is it? 100? I know mine looks different than what I have up here, but do 100 on your paper. We'll take more volunteers if we want, but I'm going to take a second to get what our paper looks like up here.
Okay, I got it.
Hold on to it for just a second, Jana. Just try to solve 100. I will be to you in just a moment. I promise. If you need a calculator, there should be one in the bin right on your table.
One in the bin.
Somebody may have taken it out of the bin and not put it back, so my apologies.
What happened?
My calculator broke. There's one in the bin. I feel like that's gonna. I think we have to have a funeral. My calculator broke. It still technically works, but taking on my friend.
That is sad, though. Now, did it break because, like, I don't know, it suffered some kind of dramatic, like you stabbed it when you got mad at it?
No, I was.
Because that's what it looks like.
It got stuffed in the trunk, and I asked for my bag to be in the front with me so it wouldn't break, but my mom stuffed the bag in the trunk.
Ah. Because that's how an LED screen works. It's liquid. Like, there's a liquid that actually is in there. That's also why they come with a cover.
That's a cover?
Well, it used to be a cover. Now it doesn't really matter anymore. All right. Jana, would you like to come solve one?
Yeah.
So that's all you want. That's why your hand was up.
Yeah.
It's kind of, that was my suspicion. Margot, would you like to do B? No? Do you want to do C? What can you multiply by to get smaller? Lily, your card's next. Do you want to do one?
I can do the last one. Did you see?
Make sure it's going to be this. That's not going to be visible. The top right things are. Go on one of the like darker palettes. If you're struggling on B, you gotta ask yourself, what can we multiply by to get smaller? I don't know what this is. It looks like one. We're focusing on that. Times 2. Turn into 1. 0.2 is not the correct decimal, actually. Where are all my calculators going, friends? So I ordered another case of calculators, like another 10. But guys, you gotta leave my calculators where they belong. Because like Christian's back here unable to test stuff because people took the calculators. So 0.2 doesn't work, but you can keep messing around. Whoa, Jan, hold on. You're not doing all of them, are you? Okay.
Wait.
Alright, you wanna talk it through?
Yeah.
Get the class's attention.
Hello.
Ah.
What's up, guys? What's up? What's up?
No, I just figured it out.
Good job, miss. Good job. So basically, I did 100 divided by 4 because I just went backwards because this is most of the tradition for like the answer, and then I went back and then I got 25, so that's how I got it.
Any questions on A? Because Jana is totally correct.
Good job, Jana.
Do you want to
Okay.
do B now?
So wait.
Or no, it was
She has a question. I have a question.
Lily and Margot. Do you guys figure it out?
Alex.
Yeah. Do you want to go up and do it?
I have a question.
Wait.
Oh, about A?
No.
Like a real one?
Yeah.
Okay, go ahead.
Okay, so
Lily, step aside real quick.
10, like 100 divided by 4 equals 400, and 10 divided by 3 equals a bunch of decimals. How would you get that to 25?
You don't do 100 divided by 3. You do 100 divided by 4 because that's the bottom of the denominator. And then you do the same. The giant one is just the same thing like both are top and bottom. So you don't actually do it divided by. You don't do 100 divided by 3, but you do 100 divided by 4.
You divide 100 divided. You do 100 divided by 4, and that's what the number equals what you're gonna have.
This is the denominator and this is the denominator. So you do 100 and then divided by 4.
That's gonna give you the answer to your like.
And then
That's gonna give you the answer to what you're dividing.
I'm the teacher here, not you. Not you.
Like on my calculator, it said 100 divided by 4. Wait, but like
Here,
I did
we're gonna go over
400.
We're gonna go. That doesn't
No,
work.
100 divided by not 100 times.
I know, but like I put divided.
Let me check your calculator because it might be a calculator mistake.
I think I used it on the other one.
I bet it's a calculator mistake. All right, Lily, go ahead and talk through B and how you
I have
figured
the
it
pen.
out.
Yeah. There's another pen right there. So.
I don't know that I would
Why?
trust your
I want
calculator.
that
one.
Wow. That's
She
specific.
wants a pen because I have it. Okay.
Trendy.
And then just back to the teacher.
That's what I thought.
Alright, Lily's gonna explain.
Here's the problem.
How do you
can't
get
see
from
the
100 to 200?
But that's how you do it. 25.
Multiply.
You need a different calculator. You can just use mine.
Alright, thank you.
Oh.
Because there's one right here.
Same thing, so another 2.
That's why I got the it was not it didn't work.
Would actually not work. But I should have checked your paper real quick. I know what you're trying to do. But the problem is they've already put multiplication.
Yeah.
Because this will work if Lily turns this into division. Now hold on. Can we divide by 1? Can I order a whole pizza and divide it just to myself? Yeah. Does division by 1 change anything? No. So Lily can do this. And that'll get her to her answer. But she has to change the multiplication to division. Which I'm not going to say it's breaking the rules, but you're doing your own thing. So let me jump in. You're right. If we did that, that is correct. But if we want to follow what they said, instead I could use, Keegan, I know you got it because I saw it on your paper. What did you use here to get from 200 to 100? 1/2.
Oh.
Over 1/2.
I didn't know you could do that.
That's why I have a job. Those of you saying, I didn't know you could do that, that's why I have a job. To get smaller. Hey, everyone chill for a second. To get smaller, you can either divide or multiply by a number less than 1. So to get smaller, we could
Minimum 1.
have either divided by 2 or said half of 200. So what is half of 42? Lily, what'd you get up here? 21 is correct. Now down here, I'm going to claim this because we have 30 seconds left, and I want to get you out. I'm going to claim this one. Fine, talk me through it if you want to. How do I figure out what goes here?
I just had a question, but never mind.
Eyes. Lily, Lindy, do you know how to talk it through? What do we do here, Lindy? Listen.
I just started it backwards and then I worked forward.
Yeah, what's that do?
100 divided by 16 on the calculator, and I got 6.25. And then I put 6.25 in the big one, and then I did 7 times 6.25 on the calculator, and I got 43.75.
That, I believe, is correct. All right, flip your papers in. Have a wonderful day. Thank you. Is that? So the only time cross multiplication works is if we have a fraction equal to a fraction. Right, so if we set 42 over 200 and we got rid of this one, we cross multiply like that, but then we have to check our 100 a different way. So what you're doing is if you were multiplying this fraction times that fraction, this number is just so you can do what you're doing, but this is still just one. Our numbers are going to get bigger. Like, I don't think you broke any rules. I just don't think you got what we're trying to do. What's up? Yeah. How many tenths? Because remember the points, the point whatever is the tenths place. So how many tenths equal 1/2? So if we do this, how many tenths equal 1/2? 5. So that is what goes here. It's 5 tenths. Yes.
5.